Now, working on a grid, as you can see, it's pretty easy for us to determine a perpendicular vector to the normals if we know exactly where the normals are facing. But let's go to the example of a sphere. If we connect a sphere here and we create normals, each one of these points has a different direction as a normal. So how can we determine an up vector for each one of those? We can't just go ahead and say, oh, the up vector is aligned with the y or the z axis, because it's not going to be perpendicular to all the points. It might be perpendicular to some of the points, but it won't be to all of them. So how can we determine a vector that's going to be perpendicular to each one of these points as normal? For that, we're going to use a little of vector math, and we're going to use the expression the cross product. The cross product is pretty simple. You basically have two vectors, and if you apply the cross product of those two vectors, if you calculate the cross product of those two vectors, the result is going to be a third vector that's perpendicular to both previous vectors. Let's say instead of using an up vector, I'm going to use the up vector for now, just so we can have a clear idea. And what I'm going to do here on this wrangle is I'm not going to be defining the normal. I'll keep the normal as it is. But let's say that the up vector is actually facing up. So let's put it back to 0, 1, 0. If we have a look at this and we're displaying the up vector, now what we're seeing here is we have the normal and the up vector, but as you can clearly see, these are not perpendicular to each other. These don't make a 90 degrees angle between each other. Some of them might be close, but most of them won't be. Still, we can actually use these two vectors that we have here to calculate the third vector that's going to be perpendicular to both of them. And that's going to be the one that we're going to be using as an actual up vector. I'm going to use another vector. Let's create a temporary vector. So it's not going to be an attribute. It's just going to be a variable of type vector. And let's say temp v. And let's say the temporary vector that we're going to be using is going to be equal to, let's say it's going to be pointing on the x-axis. 1, 0, 0, semicolon. I'm still looking at the up vector here, but we're not going to be using the up vector this way. The up vector is going to be the result of the cross product between our normal vector, our normal attribute, and the temp vector. Close parenthesis. And what we get is this nice result. Okay, we have this temporary vector which is facing along the z-axis. Yeah, but as you can see now, the resulting up vector is 100% perpendicular to all these vectors. This point isn't really going for it because, yeah, we don't have one like that, because this point is actually pointing straight along the x-axis. So this doesn't work. Meaning that we would probably be better by just generating a random point, or let me see if, yeah, maybe let's just actually use something aligned with the y-axis. I think there's no point perfectly aligned with the y-axis. Yeah, so now we have, this is going to be better. Okay, so notice the difference between us applying copying our objects to these points. They're kind of spiraling around. They all have this type of orientation, or not having any. And it's kind of random. So the cross product is going to be really useful for us to be able to properly position the runes on the hammer. It's also something that we're going to be using. Essentially something pretty close to this. So this first line just determines a temporary vector, temporary variable vector type, temp_v, which is equal to 0, 1, 0, vector pointing up. And we're saying that our up attribute is going to be equal to the cross product between our normal and that temporary vector. This temporary vector can essentially be anything you want. It doesn't really matter all that much, as long as it's not perfectly aligned with any of the normals that we already have. So on the next lesson, we're going to see how we can apply this to position our runes automatically on the hammer.